at the end of the previous presentation. That was, we see the numbers and we don't care, we just go on. And it's our part to kind of interpret those numbers and make decisions according to those numbers, which are coming from the statistics and engineering part. As you see, that's my name and phone number, email, and I'm from the Missouri University of Science and Technology, and thank you very much for attending this session. This is part of my overall study of the safety analysis for my PhD dissertation, and I picked this one to present here for you guys. Safety effect of the Missouri Strategic Highway Safety Plan, which was called Missouri Blueprint for Safer Roadways. Here's an outline. I'll present some introduction about this program and the background of the crash analysis, and then I'll present the objective of this study, how I did the study in the methodology, I'll present the data that I've used, and the results and conclusion comes next. Well, in 2004, some of the advocates of Missouri safety, they tried to form a partnership called Missouri Coalition. So this Missouri Coalition could really use this first strategic highway safety plan titled Missouri's Blueprint for Safer Roadways. So it happened in 2004, and their main concern was on education, enforcement, engineering, and public policy. And some of these examples, I can say, it's the public education as we discussed in the previous presentation, like extending the shoulder and putting rumble strips at the middle of the road or at the shoulder, and dealing with the pavement markings and lightings, and also removing the fixed objects at the roadside, which are resulting the most severe crashes that leads to fatalities. The objective of the SHSP was to reduce the number and severity of the crashes, especially those severe ones. And if we want to be specific, they wanted to have 1,000 or fewer fatalities by 2008. So they started in 2004 and 2008, that was the goal. And according to the statistics, the numbers, they found out that about 992 fatalities achieved in 2007, which was already the goal. So they reached the goal a year earlier in 2007. And also in terms of the percentages, you can say 21% reduction in the rate of fatality. So this study, if I go back here, these are statistics. What this study tries to do is to basically go over the crash data from 2005 to 2007, and basically theoretically analyze the data and see if it really shows up in the model. Statistically analyze it. So let's go to the background. Usually the researchers, what they do is to put crashes into crash prediction models. They do regression models to put the crash and the crash incorporating factors into some sort of relationship. So if you know what factors are really affecting the crashes, you can find those factors and you can put countermeasures against those factors. The previous studies that are has been done are in highway segments and the improvements on intersections, variable highway, grade crossings. So they investigate if there has been some improvements on them, what was the effect of those improvements on the crashes. The procedure that usually is used for doing these kind of observational studies. So you have before improvement, you have an after improvement. These two parts. You compare these two using the statistical models. Well, most of the time they have used empirical based model like the study of precise rating, using basically evaluating the rumble strips on the crashes, and also they have used hierarchical based model or non-parametric estimation. But these models are usually a little complex and sophisticated, and you need to have higher level educational backgrounds about that. You need to have training and experience, and also the data needs to be expensive from using all these procedures. So what is good here is to have a simpler method to come to do this, but not really sophisticated, so we can have some idea about that. The objective of this study was to find an easy to apply method or approach to do this comparison. So I'll talk about the way it was done in the methodology of the study, but here is an overview of the objectives. So 6 years of data was used 2002 to 2007. Negative binomial crash frequency models were used were developed, and then comparison between predicted crash frequency with assuming with and without the improvement were done. So basically, the models were developed, and then using these models, the crash was predicted for 2008. One time it was predicted with assuming with the safety improvements, which is the blueprint program. Another time without the safety improvement, and then you can compare the predicted number of crashes and say, basically come to an insight about the effects of the safety program. The mixture of urban and rural environments were used, and the models were tried to be developed for different types of collisions and also the crash severities. So, as you said, different crash count models were to be developed in this study. So what I did was to try to kind of categorize different crashes according to the different crash collision types, like head-on, rear-end, side-swipe, same direction, opposite direction. And also I tried to, again, divide different crashes into only fatal crashes or only non-fatal crashes, and to see how the effect really works out on different types of severities. The point about this method that I've used was to use a transition variable. So that might seem a little confusing, but I'll explain it. To use a transition variable to take care of the effect of that improvement. It goes from 2004 to 2007. So we say the value of this transition variable is 0 before 2005. Then on 2005, we assign it a value of 0.25. 2006, it gets to 0.5. And then on 2007, it takes the value of 0.75, and then on 2008 and above, it takes the value of 1, which means basically it's the progression of the safety program. So that way, if this variable found to be significant in the analysis, that means there is an effect of those safety program on the crash data. So the crash data, traffic, and roadway characteristics were used, and then negative binomial models were developed. So as I said, if this variable is significant, that means there's a correlation between the SHSP and the reduction in crashes. So now the data I'll talk about is, well, I used the portal of safety investigations from MOVITE, the SEM as far as I remember, to reach the crash data, all severities and different types of collisions and everything. For the years of analysis, all the severity types of motor vehicle crashes were used, 17 interstate highways. This is another point about the study, that I excluded all the US highways and state highways. So I'll just stick with the interstate highways for this one, so I could have an idea of what is really happening on the interstate highways. And some more data. Overall length of the interstate highway is about to 1,200 miles, and total number of crashes that was investigated was about 167,000 crashes, including all severities, not only fatalities. All right, here's the data again. Explanatory variables that was used in the model were number of lanes from a minimum of 1 lane to 7 lanes, and then lane width, shoulder width. These are basically the incorporating factors that we wanted to see how these factors affect the fatality. And then shoulder width, ADT, speed limit, congestion index, the PSR, which is pavement serviceability rate, and then the truck percentage. And I'll give you a little explanation about this PSR, which is actually talking about the pavement condition. So the higher this number is, the better the pavement is. And also the congestion index. The higher that index is, the better the more the congestion is on the roadway. So more than 6,000 segments with an average length of 2.2 miles were used in the modeling. And now let's go to the result. This part is interesting, probably. Here is the parameter estimates and their standard errors. The table here you see is showing the estimates for all those factors. It might seem a little confusing, but I'll try to make it simple and straightforward to follow. So I put some triangles here and there to explain them. Here you see in this column, you see the type of model that is going to be explained. Like the first row is for the model that was developed for all severities. Second one for only fatal, and then for only non-fatal. These numbers that you see here are the over-dispersion number that are very common in crash data. This row, you see all the variables that were used in the analysis. And the numbers that you see, some of them are bold, some of them are not. Those numbers that are bold were found to be significant, statistically significant for the corresponding model. And as you see, looking at these numbers, you see you can find out that the lane width, shoulder width, and PSR do not have any significant numbers. So we can say that these variables were not significant really in reducing the severities or the crash numbers. The other thing that we can see in this table is that, for example, the number of lanes is the sign and magnitude of these numbers. For example, if we talk about the number of lanes, you see the sign is negative, which means the higher the number of lanes results in a lower number of crashes. That's the negative sign talks about. Or